The color distribution of the milk chocolate M&Ms in 2023 is approximately as follows: 24% blue, 20 orange, 16 green, 14 yellow, 13 red, and 13 brown. Jasmine is a huge fan of the blue M&Ms and claims that the company is not holding up to their promises. In a sample of 285 M&Ms, she found that 62 of them were blue. Using a 90% confidence level and the p-value critical value methods, can Jasmine be confident in her claim? Since we are testing Jasmine's claim, she is claiming that they are not holding up to their promise of 24%. So rho is not equal to 0.24. The opposite would then be that the rho is equal to the 24% that the company is claiming. Remember that your null hypothesis is always set equal to, and your alternative will then be the not equal to. With a confidence level of only 90%, that leaves us a significance level of alpha equal to 10% or 0.10. To find our test statistic and our probability, we're going to use the one prop z test. With our p sub 0 equal to the 0.24, we have 62 blue M&Ms and 285 are in our sample. The proportion not equal to our claim is going to be for our alternative hypothesis. This will yield a test statistic of z equals negative 0.89 and a p-value of 0.3747. With a significance level of 0.10 and a two-tailed test, that means our critical value to the right of z of 0.05 is 1.645. We can now make a couple of graphs. Let's first start with our traditional graph. Labeling both critical values and shading, we can also label both our rejection and our fail to rejection zones. Placing our test statistic on the number line, we can see that this falls within the fail to reject zone. Similar with a p-value graph, we can label both the left and right shaded tails, along with the test statistic and its opposite, and the p-value. Comparing our p-value to our significance level, since 0.3747 is strictly greater than 0.10, we're going to fail to reject the null hypothesis. Now, if she changes her confidence to 99% versus the 90%, and finds the confidence interval estimate for the true value of the population proportion of blue M&Ms, does her conclusion change? Using one prop z int, and making sure that we change our confidence level now to 0.99, we find that the population proportion is between 0.155 and 0.280. We are 99% confident that the true value of the population proportion of blue milk chocolate M&Ms is between 15.5 and 28.0%. Looking back at our null hypothesis, 0.24 is the same as 24%, which falls directly in between our confidence interval estimate. So since 0.24 is an element of that interval, we're going to reject the null hypothesis. Notice how my interval estimate has a different result than using the p-value and critical value methods. Additionally, making your confidence higher in terms of 99% versus 90% also gets you closer and more confident in your decision. Since the confidence interval estimate gives you the true value of the population proportion, this is the more valid finding, and we're going to use that to interpret Jasmine's claim. Since Jasmine's claim falls as the alternative hypothesis, and we're rejecting the null hypothesis, our statement is going to begin with, there is enough evidence to support Jasmine's claim that the company is not holding up to their promises of 24% blue milk chocolate M&Ms.